Hey everyone, Professor Ray here doing activity 15, doing some activity work, homework. Looks like we're towards the end here, question 6. And we have a block of mass sum known values slowing down as it's sliding up a ref ramp. Oh no, okay. We knew it was coming. We knew it was coming when we'd be going up a rough ramp. This is the end of activity 15, right? If you have all that information, right, you can use that information again. But here we go. We're going to go through it right here, right now with y'all, right? Friction exerts a force on 2 newtons on the block. Ramp's at an incline of 34 degrees. What's the acceleration of the block? If I say down the ramp is the positive x direction. Might be a good one for y'all to know how to do and to be familiar with this problem right here. A block of mass 16, so now I'm up a rough ramp. Okay, so just gonna kind of do this. This thing's going up a ramp right here. All right. And its velocity is up. This is just going to help me visualize in terms of doing my free body diagram here. So now I have sliding up. So if it's up, that means I have gravity down, normal up that way. If you're sliding up a rough ramp, that means that the friction is going that way, right? So there's your normal, right? There's your gravity. This looks like something that we did, a couple activities ago. Hopefully that was helpful. At least you should be seeing where it's helpful now. Things go together, people. There's a rhyme to the reason, or a reason to the rhyme. Anyway, there's a point why I ask you to do stuff and work through it. Usually it's helpful later, but yeah, it sometimes takes a little while to see it. Block of mass M sliding down, slowing down as it's sliding up a rough ramp. Wow, that's a lot there. There's my friction. There's the brakes. Okay, so I want the acceleration of the block. Okay. Now, you might be tempted to be like, okay, I want the acceleration of the block. I'm going to do something like kinematics. Yeah, but the problem is it doesn't tell you anything about velocities, doesn't tell you anything about displacements. This is the best we got. All right. Other thing is we have to tilt my axis. I'm going to say positive x is down the ramp and positive y is up. It's like a left-handed axis. It's okay. It's not going to be the worst thing ever. All right. So now I have force in the x, force in the y. Same, I drew my picture. Now getting through my table. Let's see, I have 3 forces acting on this: normal force, gravity force, and F sub k. As I go through this, I have to pay attention to that coordinate axis that I tilted, right? So normal force, look at my normal force. Get this guy right here. That is just in the y. Normal force is in the y. So this is 0, it's in the positive y, normal force. How about friction? My friction is in the positive x direction. So I get my friction is just a value, right? So it's positive F sub k, 0. Now gravity is not in the x and not in the y. I have to break it up into components. I have to break this up into the components. What does that look like? If I want to make sure that I get x and y components, right, I'm going to make my y component be the opposite of my normal, right? There we go. See how that's now in the negative y, negative y, negative y. There we go. I'm going to do blue for the other one. I'm going to make this guy go, in this case, he's going down the ramp as well. So it looks like friction and gravity are working together as a team to slow this guy down as it's going up. So this is in the negative, right? All right. Now this angle right there, maybe you remember that from the activity. Maybe you don't, right? That's the same angle as the ramp. This here is FGX. The other one here is FGY. FGY is adjacent to that angle, so it's the cosine. If you don't remember this, it's just right. How to put it? Memorize it. Yep. When you're on a ramp, the y component is always going to be mg cos theta, and pretty much always going to be negative. Negative mg cos theta. For the x here is always going to be mg sine of theta, right? But it's going to be positive or it's going to be negative depending on is up the ramp, down the ramp, which is your positive direction. In this case, down the ramp is positive. There we go. Now I'm trying to solve for the acceleration of this thing, right? I can do Newton's second law for both the F net in the x, and I can do it for F net in the y. There we go. F net y equals mass times acceleration. But remember, we're accelerating down the ramp. So which acceleration do you want? You want the x direction. The acceleration in the y is going to be 0, right? You don't all of a sudden fly off the ramp, or you don't all of a sudden fall off the ramp, right? You're stuck to the ramp. You're constrained to the ramp, right? You're sliding on it, which is in the x direction, but you're not going up or down in regards to that y position, that y velocity. You're not changing your motion in the y direction. So for now, I'm just going to focus on the x's. F net in the x. That's those guys right there. I'm going to have mg sine of theta plus f sub k equals mass times acceleration in the x. Solving for acceleration, divide both sides by m, right? Now, careful. Some people might want to say, oh, there's mass, gone. No way, Jose. That doesn't work out. Okay, it'd be, if you wanted to simplify this, right, it would be g sine theta plus f sub k over m, right? That m goes to both of those if you wanted to do that. Or you just leave it the way it is. I'm going to do that, right? So I get mg sine theta plus f sub k, divide the whole thing by your mass. That equals to acceleration in the x direction, which again, that's what I'm trying to solve for. All right, check marks. Do I know the mass? Mass is given. Mass is given. I know G. Do I know my friction? I know my friction. Do I know my angle? Aha. It's all there. All there. All right. Got to go grab my calculator. All right, trusty calculator here, also known as a phone. Plug this in. So I get a mass of 18 times 9.81 times, let's see, 34 sine 34 equals, all right, so that's like 98 point something plus friction. Friction was 2, right? Wow, looks like gravity is doing most of the work here. 100.7. I'm going to divide that by 18, and I get an acceleration of 5.6. All right, it's going to be positive. Right, yep, makes sense. 5.6, it's acceleration, so I get meters per second squared. Yes? There it is. Rounded differently, but we're right there. Notice I didn't have to do anything with the y's. Could have used the y's, but I didn't have to. Right. Again, if this was helpful for you, please press that like button, because then other people will know, hey, this video is kind of helpful.